So today we are going to be talking about inverses of linear functions. All right, we're only going to be talking about linear functions. Now, that being said, when we talked about all the other functions in this class, we had our cubic and our cube root. Do you see how they're similar? Yep. Right? And do you see how the exponential and the log are similar? Yep. And do you see how the quadratic and the square root are similar? Yep. Okay? There is a reason, and it's because they're all inverses of each other. Okay? They're inverses of each other. So you're going to be seeing these inverses throughout the year as we hit all of these units. Now, for linear, a linear function and its inverse is just another linear line. So it doesn't have a fun pairing or anything. Linear inverses are still linear functions. So it says, what is an inverse? An inverse is where if you have an ordered pair AB, then BA is going to be its inverse.
So it's the problem backwards.
So it's backwards, yeah. So right up here where it says what is an inverse, right, we are going to switch X and Y. That is the big important thing for inverses, is that your X and Y switch. Okay, your X and Y switch. So instead of this being A to B, it is now B to A. Anytime you hear inverse, you switch the X and the Y. All right, for the notation, all right, F, and then it looks like an exponent, but it is not. It is not an exponent. The way you read that is the inverse of F or F inverse. The little -1, it's not an exponent. It means inverse.
Oh, because there's no negative exponents, right?
There are negative exponents, but this is not one.
Okay, how do you differentiate that?
F isn't. It's not a number. It's F doesn't stand for a number. It's not a variable.
Oh, okay.
So it's not.
Okay.
Like there's nothing you're plugging in for like the F. It's not a variable. It's a function. That's how you know. All right. So the little -1, it is meaning inverse. Okay. Hop over here to this mapping diagram. These numbers are my domain. These numbers are my range. Are domain X or Y values? X, good. And range are? Y. So if I want to find the inverse, you're going to switch them. So if my range is 1 and 2, your domain is going to be 1 and 2. And my range here is 1.2, 1.4, 1.6, 1.9. So my range will be 1.2, 1.4, 1.6, and 1.9. And then we're going to draw our arrows.
The arrows change too?
No, they're still going to go to the same spots. Like 1.2 and 1, so 1 and 1.2. 1.4 and 1, so 1 and 1.4. 1.6 and 2, 2, 1.6, and 1.9 and 2, 2, 1.9.
Why do you have a cup of food?
Why do what?
Have a cup of food.
Oh, because I had water in it this morning and I drank it all. And it's on the floor. All right. So these relations are not always going to be functions, and the inverses are not always going to be functions. Do you remember how to determine if something's a function or not? There was a test that we did.
The pencil test.
Yeah, the pencil test or vertical line test. So if you have a graph, we are going to look at the graph and do the vertical line test or pencil test. So that's one way. Do you remember what to look for if you have a table?
I think
Zero.
I think someone said it. Something about the x's.
The same X.
Right. X cannot be the same. So if we have a table, we're going to look at our x values and see if any of them repeat. So here, do any of these x values repeat?
No.
So is it a function?
Yes.
Yes. What about on the inverse? Do those x values repeat?
Yes.
Yes, because you see the two arrows coming from it is like it repeating. So is that one a function?
No.
No. All right, any questions so far?
How do you know, like, the function, like, what do we see?
If your x values repeat, it's not a function. So here, none of these numbers have two arrows coming from it. So none of them repeat. So it is a function. But here, you have two arrows coming out of 1. So that means that you have a 0.1, 1.2, and 1, 1.4. So your x's repeat. So it's not a function. All right. We're only going to do part B today. And so just these two examples right here. And we're going to do the other stuff tomorrow. So graphing linear functions and its inverse. All right. First I want to graph this. I'm going to graph my y-intercept of 2 and my slope up 3 over 1, up 3 over 1, and then I'm going to do it the other way. All right, so I get a bunch of points. You're going to put these points in the table. They don't have to be in the same order as the person next to you. And they don't have to be the same exact points. Like if you did these points as opposed to those points, you're still going to get the same answer as long as you're picking the points on the line. Does that make sense? So your answers might vary with the person next to you, but it's okay. So I'm just going to pick some of these points. I'm going to put them in my table. I'm going to start from the top. So 2, 8. 2, 8 is this one. 1, 5. That one. 0, 2. -1, -1. And -2, -4. All right, so that's my regular graph f of x. Okay, now I want to graph the inverse. So what do you think I'm going to do to fill my inverse table out? Switch them, good. So I'm going to have 8, 2, 5, 1, 2, 0, -1, -1, and -4, -2. Alright, so all I did so far to do the inverse table was I flip-flopped the x and the y. Okay, and now I'm going to graph it. So 8, 2, 5, 1, 2, 0, -1, -1, and -4, -2. So my inverse is this pink line right here. All right, one of the properties of inverses is that if you're looking at the graph, it is reflected over the line y equals x. So this is my line y equals x. It's an important property, so let's make it big and bubble it. The line y equals x is the diagonal line straight through your graph. So no matter what kind of function you have, when you're doing the inverse, it is reflected over that diagonal line every time. the diagonal line y equals x. And I can prove that to you with my patty paper.
Your hoodie name?
Patty paper? Like you use in geometry, you know?
We ain't use that.
You did. Yes, you did.
No, we
No, we
had
did not.
Alapogu.
We didn't learn.
You didn't use this in geometry.
I didn't use that in Humbler either.
What?
Let's just say.
Anyways, do you know why it's called patty paper?
Because you put patties on it.
Yeah, because if you work it like
hamburgers.
Whataburger or McDonald's,
Oh,
it separates.
sausages when you have the deep freezer.
Yeah, it separates all the burgers, and so when you're putting them on the grill, you don't have to touch it. You just touch the patty paper and flip it on
I'm
the.
scared to touch meat.
Well, I mean, you can contaminate things by touching it, but anyways, we can use this patty paper. We'll use it a couple times in this class. All right.
I mean, you already know, so.
All right, so here it is. Here's my patty paper. If I were to fold this along the line y equals x, do you see how it matches up?
Oh my gosh, it's the same thing.
All right. So I'm going to show you one more time.
Wow.
Here's it, normal. And if you were to fold it along the line y equals x,
I stand in intellection.
it matches up.
Oh wow.
All right, so
So smart.
your inverses will always be reflected along that line. So if you can kind of look at your graph and imagine this dotted line here as a mirror, it should, it should match up on both sides. It's always a way you can kind of check your graphs and make sure they're right. All right. It says, is the inverse a function? Now, the inverse of a linear is another linear, right? Are linear graphs functions?
Yeah.
Yes. So, will inverses of linears always be functions? Yes. All right. So, because your linear graph, the inverse is another linear, it will always be a function.
Why is it building like back? Like, come on.
Yes. So, we have domain and range in a step builder. Okay. So, my other question, which we talked about for this last test, what is the domain of all linear functions?
All real numbers.
All real numbers. So, is the domain for your original and your inverse going to be the same?
Yeah.
What is it going to be?
All real.
All real numbers. Very good. So, x is in all real numbers. All right, what about the range?
It's also going to be open.
It's also going to be all real numbers. And will it be the same for the inverse?
Yeah.
Yes, it will.
This is easy, right?
Yes.
Memory, baby, memory.
All right, so I'm going to call sticks on number 2, so I hope you're paying attention.
You hoped.
I hope.
But did I?
She hopes.
All right, number 2, and then we're done. 24. Jasmine, what is my y-intercept? -1. Very good. So I'm going to start here, my point at -1. 25. Haley, what is my slope?
2 over 1.
2 over 1. So I'm going to go up 2 over 1, up 2 over 1.
Numbers are broken off the big.
Yeah, I know. All right, so I got all those points. All right, so help me pick some of these points. 1. Evelyn, tell me one of the points. Good. -1, -3. 0, -1. Yep. 1, 1. 2, 3. And 3, 5. Yep, all those are good. Okay. 19. Caitlin. Help me find, so this is my regular function. Help me find the inverse points. Good. -3, -1. -1, 0. 1, 1. 3, 2. 5, 3. Someone want to come plot them?
Oh,
Sure.
on my way.
All right. Andy's gonna plot him. Hopefully, he doesn't mess up. It is being recorded, so no pressure.
Stop, I have lots of pressure. Am I doing this right? I'm so lost right now.
Why are these lines so
Good job.
My ankle hurts.
So, if you looked at your graph and you just wanted to be sure, draw your y equals x line. And is it being reflected over? Yes, it is. All right, it does look like if you folded it up, it would match up. So we are good. We did it right. All right. 11. Is it a function? Yes. Linear inverses will always be functions. 2. We don't have a 2. Leslie, you used to be 2. What is the domain? Oh, very good. And if I want an interval notation, do you remember interval? Yeah.
Queen.
Negative infinity to positive infinity. And so, last person, 12.
You thought you picked me. I saw that.
Other Haley, what is the range? Very good.
This isn't coming out
Yes,
right.
queen.